You walk into a coffee shop, open your laptop, and connect to Wi-Fi. Within seconds, you're browsing the web, streaming music, checking your email. But have you ever stopped to think about what just happened? Your device somehow received an IP address, something like 192.168.142. You didn't type that in. You didn't open any settings. You didn't call the network administrator. It just appeared. So who assigned it, and how did your device know where to ask? The answer is a protocol that runs behind the scenes on virtually every network in the world. It's called DHCP, Dynamic Host Configuration Protocol. And by the end of this video, you'll understand every step of how it works. To understand why DHCP exists, imagine a world without it. In this world, every time a new device joins a network, someone has to manually assign it an IP address. A laptop needs 192.168.110. A phone needs 192.168.111. A printer needs 192.168.112. Someone has to keep a spreadsheet of every single assignment and make sure no two devices share the same address. And what happens when two devices accidentally get the same IP? Total chaos. Network packets get delivered to the wrong machine, connections drop randomly, and debugging the problem is a nightmare. This is exactly the problem DHCP solves. It introduces a dedicated server on the network, the DHCP server, that automatically manages the entire pool of available addresses and hands them out on demand. No spreadsheets, no conflicts, no manual work. The DHCP process starts the instant your device connects to a network, and here's the interesting part. Your device doesn't have an IP address yet, so it can't send a message to any specific server. Instead, it does the only thing it can. It broadcasts. It sends a message to every device on the network, essentially shouting, "Hey, is there a DHCP server out there? I need an IP address." This broadcast message is called a DHCP discover. It's the first step of a four-step process known as DORA. Discover, offer, request, acknowledge. Now every device on the network receives this broadcast, but only the DHCP server knows how to respond. The server looks at its pool of available IP addresses, selects one that isn't currently in use, and sends back what's called a DHCP offer. The offer says here, you can have 192.168.142. That's 2 steps down and 2 to go. You might wonder, why doesn't the client just start using the offered IP address right away? Well, there could be multiple DHCP servers on the same network, and each one might send a different offer. So the client needs to formally accept one. It does this by broadcasting a DHCP request, announcing to the entire network, "I'm accepting the offer from this particular server for the address 192.168.142. This broadcast serves 2 purposes. It tells the chosen server to finalize the assignment, and it tells any other servers to withdraw their offers. The chosen server then responds with a DHCP acknowledge, a confirmation message that says it's yours. The assignment is official. Along with the IP address, the server also sends the subnet mask, the default gateway for routing traffic, and the DNS server addresses for resolving domain names. All of this happens in under a second. 4 messages. And your device is fully configured to communicate on the network. There's one more important piece to the puzzle. The IP address your device received isn't permanent. It comes with a lease, a time limit on how long you can use it. Think of it like checking out a library book. The DHCP server says you can use this address for 24 hours. After that, you need to give it back. But you don't have to wait until the lease expires to renew it. When your device reaches the halfway point of the lease, it automatically sends a renewal request directly to the server. No broadcast needed this time, just a quiet one-on-one message. The server almost always says yes, and the lease timer resets. But what if your device leaves the network and never renews? The lease eventually expires, and that IP address goes back into the pool, available for the next device that connects. This lease mechanism is what makes DHCP so effective. It ensures that IP addresses are recycled efficiently, even on busy networks with devices constantly joining and leaving. So let's bring it all together. Every time you connect to a network, a 4-step conversation happens in milliseconds. Your device discovers a server. The server offers an address. Your device requests that address. And the server acknowledges the assignment. Discover, offer, request, acknowledge, DORA. DHCP was first defined in 1993, and more than 30 years later, it still runs on virtually every network on the planet. From the Wi-Fi at your local coffee shop to massive enterprise networks with thousands of devices. It's one of those foundational internet protocols that works so quietly and so reliably that most people never even think about it. But now, the next time you connect to Wi-Fi and everything just works, you'll know exactly what's happening behind the scenes.